We are live, sir. We can begin.
And this platform to have a discussion. I think I just unmuted myself. So thank you, Mr. Murli. So then thank you everyone for providing us this platform to have an interaction with the students who are taking the courses in NPTEL. So there are certain queries that I've gotten from the students. So this is a live session for the course Metal Additive Manufacturing. So this is a new course, a fresh course that has been introduced this time. So I have certain queries which are given, which are you might have filled a Google form. I have got that in the Google Sheet. There are queries from Mr. Jishu, Mr. Arvind. The other queries, Mr. Arvind Chandra Swami. Certain things are there. So I think before that, let me have the live queries. If someone has anything, you can just come by. So let Professor Ramkumar also join. So then we will have the queries on. Or the responses on the queries that you put online. Okay, I think because internet is not stable, so I'm just switching off my video. So please pardon us for this. Okay, let me first take query by Jishu Chandran, who is a faculty. Sir, I am a faculty and part-time research scholar. I would like to know during the metal printing, is there any issue in strength of the part produced due to cooling at the boundaries of successive layer? If yes, is there any solution to rectify this? Obviously, I think then the solidification of the metal additive manufacturing components, specifically when we talked in the fluid deposition methods, so it was discussed that the solidification process and the kind of the metallurgical changes those happens, it is fuse deposition modeling and fuse and melt deposition modeling. Both the processes are possible and are there when we talk about the metal parts exactly. So melt deposition, fuse, both of these they are there. Then there are the cooling curves that as we have shown you there. So there might be defects like porosity, the boiling effect, all those things might come. The solution is the parameter setting, the right parameter setting, having a good design of experiments and keeping the physics in mind. For example, if it is titanium, at what temperature range would temperature cooling happen? And if it is like we showed you the iron carbon and the other phase transformation diagrams there, right? So there you might have seen that the temperature difference or the temperature ranges within which those work were different. So depending upon whether we are working with aluminium nickel, for example, for the aluminium, the temperature goes to some 1900 degrees or so. And for titanium and aluminium also it goes to again 2000 degrees or so. 1963 is the final temperature where the alpha phase exists. So it depends upon the cooling, the way you give the time for the cooling. It is actually always instituted in the system itself, like the sintering furnace for fuse deposition modeling that is there. It is designed in such a way. Why does it take such a long time? Because it tries to fuse off all the unwanted material. That is, first the fuse deposition modeling takes place, the model is built, then the model is washed using washer, then it is put in a sintering furnace. And why does the metal or the component contract there? Because it takes its own time. It is the annealing time or the sintering time it takes, so that the porosities or any defects in the microstructure, the quench cycle, the like influence on the boundaries, everything is controlled. So the solution is parameter setting. So there are only few metals for which we have developed the parameter setting already. For example, titanium alloys in cornell, aluminium, copper, some alloys of steel. So still a lot of scope is there to work on. Next query. Different print conditions, part orientation, layer thickness, etc., would result in different mechanical properties. Yes, of say a dog bone. How would one proceed and involve print conditions for simulation purposes in macro scale? Do they make sacrificial parts or to test the parts to know the mechanical properties which will be later be given as input to the simulation window? Yes, I think in the simulation we'll also teach you topology analysis, or topology optimization is not taught in it in the theoretical portion in the week 3 or 4. I can't just recall which week it is. But I'll also show in the forthcoming weeks the demonstration of the topology optimization and how the simulation inputs we take. And just we have the defined boundaries and defined conditions in the simulation. But also, as and when the operator or an engineer keeps on working in metal additive manufacturing, the topology analysis is always a skill. Softwares are always, GIGO. When you try to do simulation, it is garbage in, garbage out. The kind of input an experienced person gives, he gets the right output. So right in, right out has to be the goal there. So yeah, just this is a learning curve, Mr. Arvind. This is a learning curve. So as and when you keep on working, you get the information. So next is Mr. Arvind. So is there any research going on to commercialize DED? Right. Is there any research going on to commercialize DED or any metal-based additive manufacturing to process desktop level like FDM printers? Yes, obviously, Mr. Arvind. A lot of research is going on to customize the printers. There are small printers, portable printers, like even in direct opposition, etc. There are portable setups which are not yet at the mask or the I would say full scale. So technology conceptualization is always there. Like there are small parts which are there. There is a small research going on in by Professor. I just can't recall the name. It is in Germany. They have developed a portable printer for DET and for lasers also. They are trying to develop for the small X-ray systems also. They are trying to develop for the inspection a portable X-ray system. But the thing is that to bring it to the desktop level for the mass and to commercialize, the cost has to be reduced as far as possible to be taken care of or to be afforded by everyone or the maximum people. So, for that, it will take some time. The time when big companies like 3D Systems, Markforged, or big companies will take the lead and try and take this challenge to produce these kind of printers. And then it will come. The next question: is there any ongoing research to minimize the pre-processing time taken to print parts in metal-based additive manufacturing processes, especially LPBF? This includes time such as time taken to attain inert chamber using the vacuum pump, etc. In the near future, will the metal additive manufacturing community focus on making the conventional metals more additively manufacturable, or will they focus on making entirely new materials? I think this is again a too broad question, Arvind. Research is going on in all the directions. It is about the machine tool, it is about the materials, it is about the process, it is about the devising the process, it is about the hybridizing the process, like in metal matrix composites manufacturing or metal matrix composites printing, you might have seen there. So we are trying to mix two materials. So we are trying to mix metals with non-metals. We are trying to mix metals with a cheaper metal to have a support material. So everything is completely going on. And if you see research papers, there are journals on additive manufacturing. Additive manufacturing in itself is a journal name, and rejection rate is quite high. Try to see the work carried out by the recent work carried out by Professor Arvind Oli. He's your homer name. So I with IIT-Kanpur itself. So there are many things which are under publications now as well. Okay, the next question. in near future. Okay. Mr. Arvind, I think he's a student and he's a research student. He's only asking about the research, that is, which kind of research is going on. Yes, about the material, about the machine, the researches are going on, and you will get, I think that is also talked in the beginning of the course itself, that additive manufacturing has big future. It is connected to Industry 4.0 now. Industry 4.0, the major four components, one of the components along with the IoT and digital manufacturing, additive manufacturing, they call it 3D printing, okay, it's still there. But that is also one of the major components, because this allows the printing or the product to be produced in one go. With a single step, you have the product in front of you, you try to reverse engineer that, and then that product could be produced to the market in a single step. You need not to have a big setups like you used to have in the CNC machining or so. You do not to have fixtures or anything. So also the portable, it is also remote controllable, because the Wi-Fi systems and internet systems are there. While sitting here itself in my laboratory, I can control a printer which is there installed in some other city, because it is all cloud-based data. So there are so many things going on, and how to put that, and how actually, I think if you know, the uh, polymer printers are quite affordable. Within 4,000-5,000 you can get a printer. People have purchased printers for their homes itself, and they're using it for developing small build up small bits for their kids toys as well. So in metal, the costing is little high, but small the for the difficult to manufacture the intricate components like impellers, like small tools for medical devices or so, additive manufacturing is helping us to get the things done within a small amount of time. But in mass production, injection molding is still taking its own leap, or conventional machining is there. For mass production, the cost is one of the issues. That would take its time, while the multi-jet printing, the multiple extruder printing, these all things would come. So then the costing would also be at par, or maybe it might go down even in comparison to the conventional machining. Conventional, when I say it is CNC machine. Yes, I think with this I'm done with the questions which were provided online. Now, if you have any queries, you think, I think Mr. Murli, we can, if we can allow them to unmute themselves, so they can unmute and they can put their queries with us.
Yes, students, you can enable your video if the bandwidth is good, and you can unmute yourself and ask questions to Dr. Amandeep sir. Thank you.
With me, I have Professor Ramkumar as well. Though yes. I was only talking about, he was listening to me only. Yeah. So we have taken the questions now. Mr. Muthu, Mr. Abhishek, if you have any queries, please come up.
Yeah. So please unmute yourself and come if you can.
Good morning. This is Muthu. We are into manufacturing of steel castings in conventional method. So we are planning for metal additive manufacturing process. So which will be more suitable for which process is more suitable for steel casting? Can you please elaborate?
So, Muthu, there is going to be a paradigm shift in the understanding of additive manufactured parts. In casting, whatever you do, you to a large extent can dictate the grain engineering, grain boundary, and then the hardness response of the material. But when you start looking into metal additive manufacturing, all these things to a large extent gets cheated, because you do repetitive heating while the object is made. So to start with, whatever you want, you can think of making large surface to volume ratio. That means to say thin components using selective laser melting process or direct energy deposition process. So through that, you first try. And then once you start having a good feel, then you can go for large volume, small surface.
Okay.
Is that clear?
Yeah.
Here, you try with, and then see this metal additive manufacturing becomes handy only for complex geometry parts. For example, if you have currently 6 parts to be welded together to make a product or a part. So there you can start thinking of using additive manufacturing, wherein which you will try to have a break even.
Yeah, even with respect to the cost also will be a major factor, right, sir, for deciding.
Yeah,
So
see, that's what I'm saying. If it is, that's what I said very clearly, large surface to volume ratio. That means to say very intricate parts. So, and where there are a lot of parts joining together to make a part, only there you start. Because you will try to have lot of quality benefits, lot of assembly time advantage, and one-shot process.
Okay, sir. Okay.
And for this also, it is not a straightforward thing that, okay, sir, the recipe is available, I will do it. As and when you change the process parameters, the laser power, the laser feed rates, particle size, particle mixing with alloys, if you change, you have to do a process optimization.
Okay, so it will be like for the each part or each time we change any parameters, then it needs to be again re-established, kind of. That's
correct. Because Muthu, this particular idea is not available in the public domain. For example, if you have binary phase diagram, ternary phase diagram, quarter phase diagram, you are already having it in the public domain. So you know, if you go above this temperature, you get this phase, you get this phase, you get this phase. But here it is more of quenching cycle. Here it is more of repetitive heating, and while heating, it also does annealing. So all these things try to give you new microstructure.
But it can be again heat treated to the required, like either in case of stainless solution.
Post-processing step. That's a post-processing step.
Okay.
So again, after doing all these things, still you want to play with the grain boundaries, you can do an annealing process or post-treatment process, and then you can get it done. And there you also can try to do diffusion. And where, Muthu, this will be very smart is if you make a porous structure using additive manufacturing, and then if you want to do infiltration, then this process is the best process.
Okay.
So
like
going to the next question, like, anybody?
Sorry, sir. If anybody is there, okay. Otherwise, like the metal powder or wire fed systems are there. So, like in steel castings,
metal powder is good.
Metal powder
is good. Because wire, whatever set and done, it has its own dimensional accuracies it is losing. But metal powder is good, and metal powder to a large extent you can do alloying, which wire to a large you can't do much. Whatever is pre-existing, you have to use it.
How about the commercial availability of this metal powders in India, sir?
Available, sir. Metal powders are available in China market and all. It is freely available, sir. I don't know whether we will be able to buy, but in Chinese market, you get this. They are 5,000 rupees a kilo. It is there. Depending upon your requirements, it can go up to 50,000. But there are third-party vendors to supply it.
Okay, in India.
In India.
And in case of like
I think that Muthu, there is a company in Bangalore. Muthu, I don't remember the company name. There is a company in Bangalore which makes exclusively powders. At one point of time, we were working together with them on some powders. I don't remember the name, but there is a company.
Indomim, sir. Indomim, do you?
I don't remember the name, Muthu, but there are companies in Bangalore, so you can get it in India also. No worries.
Okay. Actually, we are also located in Bangalore, sir. Now, currently, we just started with sand 3D printing, mold printing for our foundry.
Okay.
We just recently started with the sand 3D printing, so we are thinking of going for metal printing as well. So that's basically.
Sure. Good.
Yeah, it is just located in the airport, like in the Bangalore airport near to that area. So.
Okay. Good, Muthu. Good. So, over to any other question, please. Any other questions?
Yes, Mr. Naveen, Thomas,
Kasim,
Prakash.
Yes, sir. I am having one question. I am Prakash.
Yeah, please, Prakash. Go ahead.
Yeah, actually, I am just asking that, for example, I have to do one metal means additive manufacturing for example, a gear, external gear. So most of the material occupying in the blank surface. Only teeth is actually the difficult area where we need to go for 3D printing. Whether it is actually have any disadvantage or advantage, for example, the other part means circular part can be do in the conventional machining, and our outer surface, gear surface can be.
Yeah. See, Prakash, you can also do press fitting. For example, you make an insert. See, currently we have the insert concept in polymers. Now, for example, the plug point inserts are made out of metals. We place it and then polymer is injected. Like that, what you can do is you can make simple geometry through conventional route, and you can try to make wherever it is complex through additive manufacturing. Then you can do a press fit or you can do a shrink fit.
Okay, that is separately doing. Suppose I'm
Yes,
just using
yes.
the blank
See,
on the metal additive manufacturing machine on that machine itself, and then trying to do the printing on the surface, for example.
yeah, that is also possible. See, when you talk about direct energy deposition, Prakash, you can try to build the part from zero, or on a build part, you want to add something, it is possible. Or if a running part, if there is a damage, there alone I have to fill. That is also possible.
Okay, any surface bonding issues will come or because
Generally in the refurbishment, what we do is we try to look at the interface. Now the metal powder, whatever you are adding on the substrate. But by and large, if it is the same, okay, so then what happens is you do a lot of preheating at the base, and then you try to take it to such a temperature such that the metal powder gets diffused. So bonding wise, it is okay.
Okay, so
but that depends on the preheating.
Okay. Then this process can be used for any, for example, that unwanted material means like main body of that gear can be do with a soft material, and only that gear surface can be do with the.
Yes. See, Prakash, how wisely, see, here is a tool. Additive manufacturing is a tool. So yes, this tool, how wisely use is your creativity. No? You don't have to make the complete part. You can make into insert separately, this separately, assemble. That is okay. Nobody will stop you.
Okay. Okay, thank
you. Okay. Anybody else? Okay. So if there are no more questions, thank you so much. You have all actively participated. And we have also learned through your questions many new things. So this will help us to fine-tune ourselves in the future. Thank you very much. And as far as this course is concerned, you prepare nicely from the slides and go slightly around the slides. Exactly one-to-one, we will not be asking at many a times. So we will go around the slides a little bit, and please try to solve all the home assignments, whatever class assignment I have told for you not to submit but to use for yourself. Please do that. The final exam paper will be based on all these things. Okay. So if there are no more questions, I would like to thank you. Me and Amandeep are very thankful to all of you for participating in this discussion.
Hello, sir.
Yes, sir.
Sir, I am from BT final year. We are doing a project on which observes radar signals. We are trying to finding the material, sir. Which process is sufficient for building like FDM or a DED?
See, if it depends upon you are trying to develop a project. In that project, what is the specification? For that specification, you should have textures, structures on the surface. So depending upon the structure and its tolerance, you decide the process. Okay?
Okay, sir. Okay.
Thank you so much. So thank you all. So we are now signing it off. Thank you.
Thank you, sir. Thank you very much.
Thank you so much, sir. We will end the session now.
Yeah. Thank you, Mr. Murli. Thank you.
Thank you, Mr. Murli. Murli has been the backbone for all the courses. So thank you, Murli.
Yes, sir. Thank you, sir.